Hi, the paper I will present today is VisQuiz, exploring feedback mechanisms to improve graphical perception. Graphical perception is a classic and fundamental topic in data visualization research. Many studies design empirical study to measure or model people's graphical perception on different charts. Cleveland-McGill's graphical perception experiment is the widely used one to measure people's graphical perception on different visual channels, and it has been duplicated by many researchers a lot of times. The task is fairly simple. We present a chart with two highlighted components and ask the question, what percentage does the smaller value represent of the larger value? The result is also very straightforward. We care about the difference between the actual answer and the given answer. On this chart, the above shows the result from original Cleveland and McGill experiment, and the following one is a replication from Hill and Bostock. This is where people draw the conclusion that position channel has the best performance. In many studies, researchers ask participants take graphical perception experiment, collect the response, and run the data analysis. That's a typical study workflow. Participants have no idea of their performance and cannot learn from it. If you notice, the graphical perception experiment is very like a quiz-style question. It has the actual standard answer, it has the error rate, we can generate infinite questions. There is an opportunity people's perception can be calibrated and their chart reading skills can be improved by using this quiz-style experiment. These questions can be used to calibrate people's graphical perception and also be used to test the result, just like how quiz works. All this vision is based on if we can provide proper feedbacks. Participants can take this quiz, learn from feedbacks, and calibrate their graphical perception and improve their chart reading skills, just like how quiz are supposed to work. So what is the simplest feedback for these questions? Yes, we provide them with the correct answers. Our pilot study shows simple feedbacks with only text description cannot improve people's perception performance. We definitely need to provide more detailed feedbacks that can guide participants calibrate their graphical perception. Here, I present the animation-powered visual portrayal feedback. This example using bar chart. As you can see, two components are selected for comparison. The dashed zone indicate their input answer. It appears in component that represents larger value. The orange zone indicates actual answer. It appears on another component that represents smaller value. Then the actual answer will move to another object, overlapping with dashed zone for more intuitive and heuristic comparison. A letter grade helps participants know their accuracy level at a glance, and the text explanation provide numerical details. Here, let's see some live examples. This is a slow motion of how a participant receives feedback on a bubble chart trial. The circle of the actual answer will move to overlap with given answer for easy comparison. Here is another example. The actual answer slice will rotate to overlap with given answer slice in pie chart. The above slides show the per-trial feedback. After participants complete a session contains dozens of trials, they will receive a summary feedback page. In this page, participants can find out the result of each trial in this session. They can hover over a letter grade to check details, and they can click on a letter grade to replay the feedback animation. This is an example for the bar chart. Here is an example for the stack bar chart. And the bubble chart and the pie chart. We have seen this animation in previous slides. As you can see, we designed different animations for different chart types. We launched a crowdsourcing online experiment through Prolific. Here is the experiment flow. There will be two conditions. Condition 1 is the one with per trial and summary animated feedback, and condition 2 is the one without per trial animated feedback. Each participant will be assigned to one condition randomly. On calibration stage, which is stage 1, everything is identical between two conditions. They will take the graphical perception experiment without any feedback provided, and they will receive summary feedback at the end of Stage 1. Stage 2 is different. On Condition 1, participants will receive animated per-trial feedback and animated summary feedback as we've seen on previous slides. On Condition 2, participants will not see per-trial feedbacks, but they will still get a static summary feedback without animation. Stage 3 is a quiz stage. No feedback will be provided for both conditions. This is a confidence interval plot for average response error. We can find out clear performance improvement. If we take a closer look, in bubble chart, the performance improved more in feedback conditions. We also collect feedback from participants. Almost all participants give us positive comments for animated feedback pages. A participant described it as a rearranging your mind. And some participants changed their strategy of retrieving data values. A participant said their strategy to read pie chart has changed from Arial to Radius. For future works, first, we covered 4 chart types in this study. We can extend this work to more chart types. Second, the graphical perception experiment tasks are very low-level tasks. Extending this research to high-level tasks is the next step. Third, we launched this experiment on Prolific Online. This study has a potential to be part of schooling education. More research could be done about how to improve students' graphical perception performance. We can adapt VisQuiz to educational settings. That's all of my presentation. Thank you very much.